This livestream series is sponsored by Slice Engineering and the Mosquito Magnum Plus Hot End. Push absurd amounts of filament while maintaining the structural integrity of the Mosquito design. The Mosquito Magnum Plus can be configured with up to 100 watts of heating power, redundant 500 degrees Celsius rated thermistors, and air or water cooling. I'll be using the Magnum Plus for this build, and you can find the links in the description below. Also, Do It 3D, the Voron printed forward team, and Lineo were kind enough to provide some of their high quality parts for this build free of charge. I've purchased the rest of the parts on the regular, like the FormBot kit, upgrades from Fermier Labs, and little bits here and there. You can find links for everything in the description below. Now, let's get started with the build. Welcome everyone to the next part of this Voron 2.4 live build series. I'm kind of confused right now because I lost my audio feedback on like that intro music. Usually I have that on one of the screens playing, but I'm hoping tech is working today. Quick round of updates today because quite a bit of stuff changed since the last one. So first of all, you may notice it. I did change the audio config slightly, so it is now compressed more. There's also noise reduction on it. So when I'm back here, you muted? No, I'm not muted. No. So when I'm back here, you should be able to hear me a bit better, and it shouldn't be as noisy. What else? There's a correction that I need to make that was pointed out to me from von Wengen that I attributed the printed parts to in the very first. And I can also not hear those tips. Hold on, if I drag this up, I can at least see the levels. Okay, there is a correction in the attribution to the printed parts that I'm using. Those are not from von Wegen, those are from Stefan from the Voron community. He printed those, not von Wegen. The von Wegen coupon code that was included is just included with every one of the printed forward sound kits. God, I read sound and I say sound. Okay, is included with every one of the printed forward printed parts kits. So that is Stefan. Thank you, Stefan. Not CNC Kitchen Stefan, but Stefan from the Voron community for printing these parts. These are amazing. Then, what am I missing? Chat. I love you guys too. I love you too. I love you too, random citizen. If you guys know that quote, like you have a fine taste in movies. Anyways, I got a new tool. I got a new toy. We were discussing on the first stream, like why am I using power tools? Why am I using the Ryobi? I don't have my impact driver here. This Ryobi driver was a stopgap solution, right? So I tried to use something that was actually purpose made, and that is the Bosch Go. So this is basically, so people were bringing up the ES 121 or 120 screwdrivers, which are much smaller than this. And I guess they're made for like disassembling laptops and phones. So I thought like, well, let's get something that is a bit chunkier, a bit beefier. So this has a torque clutch. Actually, I can stop the bit right here, and I will be using this. It does have a good amount of torque too, but yeah, it does have a clutch that's adjustable, and hopefully I can use this to drive M3 screws a bit more quickly. So that's that. You're going to be seeing that in the stream. What else? Yes, I printed off some new parts, as you can see. So because I'll be using the Mosquito Magnum, the standard printed parts for the... What is this? This, I guess, is the Toolhead base? Whatever this is called. These two parts that I think... I mean, I've not assembled this before, but I think this is where the X-axis carriage goes, basically. So that's where the carriage goes. Down there is where the sensor goes. Oh yeah, I think the spool was dragging on my Prusa. That does not look nearly as good as the printed forward parts. But yeah, these two parts I've printed off. These are longer than the stock one, so the bed sensor is dropped down further because the nozzle is also down further. X carriage, okay. Thank you for that, Raymond. These parts I've printed, and I have also printed off a new fan shroud. I guess I'm calling this fan shroud because that's what it is to me. That is the stock fan shroud. I guess this is the one that actually goes with the Mosquito. And I've printed off a longer one, and oh, hold on, this one. And yes, it is slightly warped, but that is because this is polycarbonate. So because that Mosquito Magnum has such a large heater block that does not have any sort of insulation around it, it does radiate off a lot of heat. So I thought like, well, it's not going to hurt to have these parts in the most temperature resistant material that I can think of. So polycarbonate, well, Pushament polycarbonate or PC blend. One thing I would like to point out, so I have 3 different versions: polycarbonate, ABS, that is eSun ABS Plus, and then a nylon carbon fiber. I just want to have you guys listen to how different these sound when I plop them against the table, because that tells you a lot about the rigidity of these different materials. Of course, this is a different geometry as well, but just give it a listen. ABS first, then the nylon, carbon fiber reinforced nylon, and then the polycarbonate. And the first time I plopped this onto the table, this was like, wow, this sounds chonky. And it is chonky, it is quite heavy. ABS, polycarbonate, nylon with carbon fiber reinforcement. So this is the part I'm going to be using, the extended fan shroud. Actually, this is kind of cool because the fan actually blows in the top and then it gets channeled all the way down around the hot end cooling fan, I guess this is going to be, and then down to the bottom. So these are new. We're not going to need these. Right. So today, the plan for today is to assemble the Core XY gantry, or I guess it would be an AB gantry. Well, it's not an A and B axis, but it's the Core XY gantry that is actually Core XY also moving along the Z axis in the frame, which is down here behind me. Maybe you can, yeah, it's on the floor back here. Hopefully we can have something that kind of moves today. So like the last couple of streams, we're going to do roughly 3 hours. I know 3 hours is roughly the amount of time that I have before my energy runs out and my concentration runs out. And yeah, I would rather split this up into streams that are actually watchable instead of me just messing up left and right, which I have done. So let's not do that again. What am I missing in chat? Not much. All right, cool. Then let's jump in. Oh yeah, one suggestion was to add the CAD model and to have that open on screen cap, but I would find that a bit too much. Having to switch between the manual and the CAD model and having another computer doing OBS and all that, a bit too much. A bit too much. Sana, by the way, one of the loading screen tips is drugs stopped being cool in the 80s. Don't do drugs. And I fully stand behind that. So let's jump in today and do the XY. So we have the Z rails. This is actually the Z rail bearing here. And yeah, basically this is the real core of the printer. This is all the moving parts. Yeah, this is literally all the moving parts, yeah. So basically, X-axis, Y-axis, Z-axis is all in this one assembly. So let's try and get this built. Step 1, dual rail install. Okay, so this was something that I've been told by the Voron guys, is to not do a dual rail install. Let me grab a couple rails here. We need the second shortest, so this one. And that was to kind of make it easier to assemble, because installing the rails on the front and on the bottom is just a huge pain to align. And they've just told me, hey, you know, do the front rail and it's gonna be rigid enough. It's gonna be fine. And we're doing this. Where is my? Oh yeah, I've got 3 more rails. Okay. Rails are behind me. These are the good rails that I picked out. We did sort through all the rails that we have. And I have one more rail in the box that I'm not going to be using. That is going to be a spare if we mess up, which I hope we don't. But these are the 3 better rails. The other 2 here are going to go on the y-axis then. All right, so this is the same as always with these rails. M3 by 8 is going to go through the front, and then we do every second hole, and we're going to use the T-nuts that we're using for everything else on this build as well. So these are the M3 T-nuts again. And the cool thing is, because we have this profile open, we can just slide it into the end. We don't have to tilt them in. So we're going to need 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 T-nuts, I guess. 3, 5, 9, 10. So basically, just slide them in from one end and count to 10. Is there any advantage to using a high temp thermistor like in this Holland over a PT1000, or are they about equivalent? Not to be confused with the PT100, which needs an amplifier. Oh, I've actually not used the PT1000s, I think. From what I know is that thermistors are a bit harder to make suitable for high temperature or for the high temp ranges. I would guess that a PT1000 would actually be the better choice, but it might have more limited firmware support. Just, you know, having the right lookup tables, if it actually can be used without an amplifier in a standard. Oh, that thread looked kind of iffy to me. So these just get spread out to where the holes roughly are, and we're going to align them in a second. Actually, yeah, we can do that as well. So on one side there's going to be a double block. And then basically just put this on top, and this needs to be... So this needs to be centered on the rail, on the profile, and it also needs to be centered left to right, I would assume. But it probably doesn't have to be like super perfectly centered. Let's see. We have about 15 millimeters on each end. I guess if we put 2 more blocks here, yeah, we can roughly center this. This is going to work. Bolt the nuts to the rail and then slide the lot in on one go. That could, I guess that could work too, yeah, but just getting them started and getting them like not clipping onto the end of the rail, that might be a bigger challenge than lining these up once. So these stoppers, again, these are kind of important. There we go. So this rail has these rubber stoppers in it, and maybe you can see right there. Yeah, these just stop the carriage from sliding off, and when it does slide off, you are going to lose some of the bearing balls. So if you remove one on one end, at least put it back one hole over if you need that hole. And until you're ready to have the printer in service, and until you have this sufficiently like tied into the rest of the structure for this to have no chance of sliding off, leave that stopper in. Because it is much less damage if you run the printer into one of these stops once, twice, I don't know how many times, than sliding that carriage off of the rail. That is a surefire way to maybe not permanently damage, but I mean, if you can get all the balls back, but it's a very high chance of degrading the rail. They can run with 1 or 2 balls less, but they're not going to run very well. They're going to be noisy, and they might jam. So try avoiding that. And actually, we need to move this one more over if you do it that way. Now, typically these rails have one side marked, and this one does not. So on these rails, at least on the bigger ones, one of these sides has a groove cut into it. Actually, there's some styrofoam here. One of these sides has a groove cut into it, and this one does not. So both of these sides here are identical. Typically that groove, if I remember correctly, is the side that faces down. So your load is supposed to go this way with the groove facing down. You can look that up in the data sheets. So if you ever use this type of linear rail. I think it's more of an issue for the larger ones. But yeah, I guess there's some pre-tensioning or something that is in there that would make them better suited to be used with that marked side facing the correct orientation. So is this roughly centered? I can measure in a second. Oh yeah, let's try out the Bosch. Let's give that a go. So M3/8. This is on the lowest torque setting. Whew. And this one has a weird activation mechanism where you push the bit into your screw and it goes. I think that's not too bad. I think that's something that they came up with, and it does sound a bit weird to me to have it activate like that. Oh yeah, and the button is like super sensitive. But that actually works pretty well. In like, oh yeah, well that doesn't work very well. The bit holder is kind of crap. But actually in like assembly line style assembly lines, what you typically have is screwdrivers like this as well that quite often are just dangling down from the ceiling. And yeah, this one does have a kind of a loophole up here too, and that just dangles down from the top, and the assembly worker basically just grabs it and pushes it into the screw like that. So it dangles down, they just push it into the screw and they can let go of it. So this, as is, just stabbing it into the threads, feels pretty good so far. Like I said, I've made some bad experiences with Bosch tools in the past. You've seen me use the Bosch, like basically the Bosch equivalent of this Ryobi drive in the past. And that has broken. My other 12-volt Bosch tools have broken just out of warranty. So this is kind of my last hooray, my last chance that I'm giving Bosch to deliver a decent tool. Yeah, the button is kind of, or the push activation is kind of weird still. You stay here. Oh, you enjoying that look of the screw back there? I did miss one super chat just now and one a minute ago from Josh Kaiser. Thank you for the 5 through super chat. Let's get this bread. Let's get this bread as in like breeding horses or something, or let's get this bread as in actual bread. Thank you for that, and thank you for the 2K. When are we getting that hot and steamy studio tour? Are you guys interested in a studio tour at all? Might just be the bit as well, because so far like studio tours and gear overviews weren't all that popular in the channel, so kind of stopped doing them. But then again, this studio isn't much. Like, this studio is just in the same room I've been working out of for, I don't know, 5, 6, 7 years now? It's just, yeah, the way it's set up keeps, the way it's set up keeps changing. That's the only thing that's happening, but so far there isn't much of a studio. Duma Brasov is asking, hey, aren't all the screws a little overkill? Go back like two streams about the Voron 2.4 build, and I mean, that question isn't X a bit overkill. You would be typing that out over and over and over again. Like, at this point, I'm past questioning whether you really need all of these screws in the profile, but why not put them in? Why not put them in? Right. Pug of Stardock, glad I could help you out with choosing a good mic for your camera. By the way, I have just updated that my gear list on my website. That is toms3d.org/my-gear. I've now listed all the equipment I'm using right now and I'm using for my regular videos. So if you're interested in that, yeah, I think it's also linked in the description or somewhere. So that's in. Next up, so what is this? This is the left XY joint assembly. I'm guessing that is going to be the first attachment point for one of those linear rails that we're going to encounter. But I guess we're building the x-axis first, and then we're setting that into the xy or into the y-axis. All right, so let me grab some of those printed parts for that. So you go there for now. I guess this is pretty much all the parts we have left. It is starting to clear up quite a bit, because this was a huge amount of printed parts when we started, but look about right, and you are the same thing but mirrored. But yeah, it is. I am starting to see the light at the end of the tunnel. Don't walk into the light. What model Bosch screwdriver is this? This is a Bosch Go. It's literally just called that, a Bosch Go. I shall link it in the description below after the stream. Bosch Go 2, actually, the 2 has the button on it. About $60. And I don't know if I like it yet because I've not used it that much yet. So there's our printed parts. As always, we have a set of not mirrored parts. Okay. So these look mostly identical. They look like they're mirrored parts, but they are not quite. So that goes like this. Okay, so that's different because it's a Core XY and it has two belt loops around it. So these are not quite identical. You can see that big hole right there, where some sort of idler is going to go. That is in a different spot on both of these. All right, we are assembling. Hold on. First, I've made that mistake before. Pick the correct part first. So we need this one, and the other one I can't see in the manual. The other one is impossible to determine, but I would guess the one that this fits onto. That would be, yeah, that would be this one then. So we have kind of the opening right there where a rail is going to fit in, or an aluminum extrusion. And then these three holes line up. And that looks like it's the correct part. So if I do this, and then I do that. Yeah, that looks good. And this other part would be mirrored. That looks like this part in the manual. So, M5x40 socket head. M5x40 socket head. M5 this is the mega oily bag, the one that already has oil seeping into the label. Oh, and I'm out of paper towels. Oh no. Oh no. Oh well. So, four of the M4x40s into all of these holes. Hold on, but why does this one have a through hole? That is interesting, because this bottom left hole, this one right there, yeah, you can put an M5x40 in it, but it's not going to stick. So it's just here. And then this, go over here. So now we have a whole bunch of parts that we need to thread onto those. Bearing stack, see previous examples, but yeah, okay, so this is shims. This is shim, and then those flange bearings to those. I'm running very low on those flange bearings. So front, let me try and align this the same way that the manual does. I guess it's like this. Yeah, so that's the front one. This loose one is the one that gets the shim and the two bearings. So I'm going to assemble that outside of that assembly. It just makes it a bit easier. There we go. There we go. And we can plop this one in from the back. Like so. But this is only going to get threaded into that side, into this part then, I guess. There is one, and then we need an idler. Where is my idlers? God, there's so many parts in this build. It's crazy. I don't know if it's more parts than like an ender or something, but it feels like it's just a lot of individual components and bags and stuff. So this one has, yeah, this one has the tiniest lip. So in this position right there, you can see it has like a super tiny lip on it that allows that bearing in the idler to ride on. Wow, and that has like no clearance. That is literally one layer of a lip right there. Wow. Whew. Thank you for the 5, Tuma, for the unnecessary screws fund. Yeah, well, I've talked about screws before, but like screw assortments like this are very necessary. They cost a bit to put together, but they just make life so much easier. So that goes there. That's that, and I think that is all the... Use the same bearings and fasteners as used in other steps. Okay, but that is all the parts that we need. Now we just need 3 of the nuts, except for the one that has the idler bearing on it. So this one does not get a nut, but yeah, there are 3 nut holes right there. Where is there's the M5 nuts. Any feedback on the new audio setup? So I think the most easily audible change that I made was to add the noise reduction. So that might be something that could be a bit jarring when I move off camera and then come back. That might be a bit weird. Hold on, how does this go in? Like that. Like that. Oh. But does that work? Okay, sounds good, sounds good. Where's my screw with the... There it is. We need this one as well. Yeah, might want to put that in, sure. Manual tip, I will... So, one thing I will do... Oh, that threads in interestingly. One thing that I'm going to do is... Well, after this stream series is done and once the printer is printing and going, is just to go through the entirety of the manual and put notes in there and just go like, hey, you know, this step isn't clear, or this step could be easier if you do it in a different order. All those things, and just send that over to the Voron team. I think that is the best way to give feedback on stuff like this. I'm gonna have to do that pretty quickly after the build. Is that not an M5x40? Because otherwise I might not remember all the stuff I run into. How does this go in? Supposedly. That's this. No, that's the wrong. Hold on, that's the wrong hole. That's, first of all, that is the wrong hole. That is indeed the wrong hole. Okay. That's what I'm saying. Like, this stuff is intense as far as trying to concentrate and do stuff correctly at the same time. So this is, let me just try and line these up. So this one stays on here. And then that's the correct orientation for that. So this one with the idler bearings is going to go in this hole. So, okay. And then this one gets a nut. All right. Okay. Close. Then there. Okay, so these two get nuts, and then this one with the idler just gets threaded into the plastic. There you go. So that doesn't need to be super tight, because otherwise you're just smashing that bearing and stopping it from rotating freely. Now, 2 more nuts in the back. So yeah, I am still using the Ryobi for this, because for an M5, this clutch is fine, and also I don't need to swap bits from the M3 to the M5 the entire time. That is the reason why I'm using the Ryobi here and not the Bosch. The Bosch, I've got the M3 bit in, and I will keep using that for that. There's one part done. One of the XY joint assemblies. And then the right XY joint assembly, I guess, is mostly the other one, but mirrored. But we have this little extra, I guess, neck on it. And that is for the drag chain, if I can tell that correctly. So, same idea for those bolts, screws. I guess one of them is a screw and the other two or the other 3 are bolts. Huh. Yeah, like technical definition of screw versus bolt. A bolt is something that threads into a nut, and a screw is something that threads into material. So because we're threading into plastic here, I guess one of them is a screw, and the other 3, because they have nuts, are bolts? I don't know. They're all the same to me. So on this thin, okay, so this is swapped now, I guess. So on this thin front part right here, this is where the toothed idler goes, and then so I guess this one I shouldn't attach to the top plate because there's nothing holding that in. I should just attach that to this part right there and screw it in right there. That would be a lot easier. Tooth idler. Part-time Ronin, yeah, you might be correct on that, because that is all the bearing size that these little toothed idlers use. They have extremely small bearing balls on them. So if you crank down the belt tension with this sort of idler, I can definitely see them failing much too fast. Oh, and that is also... Is that the correct hole? Yeah, there is a little flange there. But idler is binding when I just hand tighten it. So this one is slightly binding. Use bearing stacks instead. I don't have enough bearings for that. These two are my last 2 flange bearings that the kit gave me. So my only choice here is to use this and possibly a washer. Don't tighten this one. Don't tighten this one. Part-time Ronin, no, there is no need for a shim. The problem is, even when I leave this one just ever so slightly loose, I can already feel it binding, and this might tighten over time and give me issues. I do not like that. I don't like that at all. Is this, let me see. So if I push down against the screw head, yeah, that's good. So the screw head is fine. The screw head size is actually the plastic side. Let me see if a washer is gonna work. I'm not gonna use a shim. I'll just grab a regular M5 washer. Yes, Nero, I believe that is possible, but like I said, I'm out of those bearings. I don't have any more of those. Let me see what I have. I'll be right back in a sec. I'm back. So I found some more bearings. I found some more of the, there they are. So these sealed bearings are the ones that are included with the FormBot kit, and these are the ones that I found, and I think they are the same size. Now the alternative is to just use a washer, and just to grab this thing, put a washer on here, and then that's also binding. That is also slightly binding. So the question is now, what is the height difference between this and the bearing stack? So I don't know what printer these are out of. Some printer, I don't know. Yeah, so that's about 2 washers off in thickness. So if we try 1 washer there, bearings here, because the alignment is still going to need to be the same. That looks about the same to me, but the washer actually needs to go on the other side, because this screw head can just tighten down more. But this washer right here is actually going to sit against the material. And yeah, this is free to rotate as well. Put a washer in the middle as well. So far we've not needed a shim or a washer between those two bearings, so I don't think it would be necessary here. Matte, it is binding against the plastic, so it is binding against that little lip right there that's supposed to be in the printed part. You can maybe barely make that out, like right there, that's supposed to be a bit of a lip, but it's literally just one layer. So it's getting pressed down just by the slightest force. Or I don't know, it might also be that these bearings in the idler are pressed in just a bit too much, because they barely have a shoulder on the inner race. Yeah. Nero is checking his printer right now. Thank you for that. For the time being, I'm going to go ahead and use the washer. against the printed part. This just spaces off these two bearings a bit further away. So toothed idler not okay. I would say the tooth. Oh, we are bottoming out. So I will need another washer in a second here. Yeah, only grabbed one. Washer, bearing, bearing, washer. Okay, I will grab another washer real quick, unless I actually have one here, but I don't think I do. Yeah, this screw is bottoming out, so it does need another washer. Just to, I could drill into this hole as well. 1 second. I should probably put like a, just leave this perspective on and just put a little banner on the bottom. I also found some paper towels. That's going to be handy because all these screws are coated in some sort of oil, which is nasty to work with, and everything is greasy and slippery, and anodized screws are the best still. So that works like this, and this goes on. And then another washer. By the way, for washers, these are cheap stamped washers, and they have one side that is actually that is sort of rounded over. This side is nice and rounded over, and this side has that sharp edge. And typically that sharp edge just stands up ever so slightly. So if you ever use these to put a bearing up against them, which is not the intended use for how you're supposed to use a bearing, always make sure that that rounded edge, so basically your stamping tool while they're making these comes down from this side and kind of rounds over this corner. Always make sure that edge is towards your bearing so that you're not getting that little lip that stands up or that little burr standing up into your bearing. Yes, shims are better than washers, but if all you have is washers, then you got to use washers. I do have some more shims. There are some more shims somewhere around there. There's all the shims that were included in kits, but I don't know if they're going to be enough if we use the shims now. Oh yeah, that feels good. I'm just going to hand tighten this because this is threading into plastic, and it's very, very easy to strip. There's a bit of slop like in this direction, but it's not too bad. This is going to be on tension from the bearing, from the belt anyway, so it's going to be fine. So the next parts are this right here is that toothed idler that we're supposed to put in there. So we're not going to put that in there. Instead, we're going to move on to we've replaced that with a stack like this. So next up, we build the actual bearing stack. And this one will go into... this is so hard to visualize. That's there. So that one, this one is where that that supposedly toothed idler sits in, and then this one further towards the front, but this one also has the little lip in there. Huh. Interesting. Yeah, but this gets a shim, stack of washers. Here's the shim, washer, washer, shim. So these shims are slightly thicker than the washer, maybe? They look thicker, but they might actually be the exact same thickness, but they're definitely made to a better precision. Accuracy. Precision? I guess accuracy. So these are, from what I can tell, a millimeter exactly. And washers can deviate quite a bit in thickness because they're not, their thickness is not super critical. So basically just 2 more screws through here. 1, 2, and then nuts from the back again. 3 holes for nuts. And everything gets tightened down. As always, looking for my nuts. And since I don't have any audio feedback today from OBS Studio, somehow that got messed up. I missed a super chat again. Thank you for the 2. Jay Shea was asking about like how does this compare to Prusa i3 Mark III? Yes, it's a different. I mean, it's a different experience, right? This is a much more involved build. Well, I guess, yeah. It's less hand-holdy. It is less Lego-like, though. I mean, the build so far hasn't been bad at all, actually. But they are different printers. They are, you know, built by different teams with different intentions. It's just a totally different printer, so I don't think you can really compare them as is. But overall, this is kind of the more involved and more capable in the end printer, but also one that requires more of you to build it well and to use it well. I would say. Again, I've not finished the build yet, so I can't really comment on what it does and what it does well and what it doesn't do well. So yeah, but definitely this is the more hardcore printer option. So that's that. I guess it's pretty hard to assemble this wrong. If you put a washer stack on one of the wrong screws, it's not going to close down. So that's that. But next up, we need the micro switch pod. But that is that for a micro switch? That looks like it's for a drag chain. Is that even the same part? That's not even the same part. Okay. So, heatsink inserts, which means I get to fire up my soldering station over here. And we have the correct tip loaded up. Heatset inserts. 2 parts in there. Okay. 2 parts, 1 for cables, 1 for end stops. All right, but the assembly step is just literally called the micro switch pod. So that's that, and okay. There is all of that, which we're going to get to in a second. And next up, I guess we actually get to assemble an axis. Wow. Heatset inserts into, these are accent colored parts, if I remember correctly. It should be, nope. Yes, that's one. That's the one that gets the heatset inserts. And then, we have 2 of these. Oh, we have one with 2 and one with 3 holes. Okay, so I guess I need to pick the correct one for the drag chains that I have. And then here's that other part. Tom, did you install the heatset inserts that were missing at the end of the last stream? Oh, I did not. I still need to do that. Yeah, I need to install those. Okay, good point. Thank you for that. I may have missed that. So for these, first let's finish these and then do the heatset inserts on the guys that we assembled the last time. So 2 holes or 3 holes? I guess that's going to depend on which type of drag chain I have. So these are the drag chains that are included with the kit, and that's 3 holes, that's 3 holes, that's 3 holes as well. So I'm guessing I'm just going to need the 3-hole version and not the 2-hole one. I think I want to grab a parts holder for this one real quick, because that's going to be... This part doesn't stand up on itself, on its own. So 1, 2, and these parts are ABS as well, just like the black ones. So inserting these should go pretty much the same. Paul's pointing out that, yeah, genuine Aegis drag chains use 2 holes, and most of the cheaper Chinese ones use 3. Yeah, you would need the 2 different mounting standards to be covered, and it's cool that the PIF kit includes both of the different options. Yeah, that's flush. And my overkill tooling for building? What do you mean? The fact that I have 5 cameras on me? Okay, so that's these. That's the inserts on this step. Look at that, heat set insert. I love these. So I've got a whole bunch of the cheaper. Well, actually, I have them here. Hold on. I have a whole bunch of the cheaper heat set inserts, and like they're okay. They're okay. They work as a heat set insert, but they're not the strongest. They're not particularly good when it comes to actually holding into a plastic part. So this is the comparison of there, that tiny one, that is the one that I have, that those are like pennies a piece, and then the slightly larger one is the one that is included in the kit, and I think the one that is required for this build, because the hole size is slightly different. So how close can you focus? There we go. And obviously the one that is required for the Voron has those rotating teeth to it, so it can't really pull out, whereas these cheaper ones just have straight teeth, so I guess they could pull out. Now if these just had a gearing to them, or a screw thread on the outside to them, they would be super easy to pull out as well, because they would just unwind out of your part, which is why they need to have that herringbone counter-rotating component to them. Alright, let's do those AB motor parts. The crappy ones are meant for injection molding. I guess that makes sense, because for injection molding you have them much better encased, and you don't need to worry about the material flowing over them as you insert them. Okay, let's do the heat sets that we forgot last time. There we go. So that's 2. I guess those go on. Nope, just on the one. Just on this one. Just on this one and not on this other one. 2 nameless parts. I guess these are AB motor holders. And this one has the 2 extra holes for getting some heat sets in there. No one watching the German versus Finland hockey match? I mean, if that's your style of entertainment that you're into, that's cool. I'm not watching that because I'm building a 3D printer. I mean, you get to choose which one of those is more exciting. I think the polycarbonate parts that I printed off, they also get some heat sets. That's going to be interesting to set into, because polycarbonate has a bit of a higher, well, softening point, glass transition temperature, whatever you want to use as a reference for when a material melts or it gets soft. And I don't know if we're going to use those today, if we're going to get to that today, but like I said, that's going to be interesting to assemble. That's kind of, ow, that is still hot. That's kind of bowing apart, but I guess there's going to be, yeah, this is going to get tightened to a rail, into an aluminum extrusion, so that is going to be very tight in the end. That's done. Okay. Screen cap. Oh, hold on. We actually forgot a part too. Ha! I wouldn't have noticed that. So this guy that we just inserted some heat sets into, this gets that one printed part that I wanted to use just a second ago. That is this one. So does that actually have that looks like a wire guide. It's interesting. So that just goes over this entire part right there. Like so. That looks like a wire guide to me. However, the manual has no description of what its function is. We might need to take it off again. Yeah, that's that part back here. Best to put it when doing the wiring. Okay, so it is a wire guide. Ha! Manual. I beat you again. Manual didn't want to tell me what it is, but figured it out anyways. Ain't I smart? So yeah, I mean, the fact that the motor cable is coming out here and then basically it would make sense to go through this entire part and then coming back out here. Cool. So this part, we will assemble that later. Also, yeah, by the way, I will need to crimp some, what are these, Molex Microfit Junior connectors onto these. So that's going to have a connector right there. Actually, this is the wrong part. Connector right there, and then the wiring loom, the red wiring loom that I'm going to be using with the whatever. Those cables, that's going to go all the way up to this guy with the matching microfit connector. So these motor cables, they're 1 meter long, will not be used for the most part. Okay, so that was this part that was supposed to go on there. I guess maybe if those could, if the accent parts could just have, because this is like a visible edges kind of display mode or view mode. If those could just have the edges in red, that would already help a ton. So we did that, we did that, we did that. So now we're at heatset inserts. And we're going to install 2 micro switches to the XY micro switch little plate. So, micro switches. And then we need the little M2 screws. Here. It's kind of nice to have this all in little bags. Of course, if it was in like an assortment box, that would be even nicer. But having these in kind of little resealable Ziploc bags, that does work very well. So do we remove the little actuation levers? It does not look like we're supposed to do that. We did remove it for the tool length sensor, and now that is just clicking directly, I can't see that, directly onto the micro switch itself, but the levers on these, they stay in place, and they are pointing counterclockwise. So look at that, they're pointing counterclockwise around. That often is quite important to get right, because the actuation might happen on one end of these levers, and if you have them the wrong way around, they're not going to work. That's a little 2mm hex. Am I going to use the Bosch? Nope. Not when we're threading into plastic. Where did I just had that little hex key a second ago? I guess I can use just a fair bit. No, that's a 1.5. Okay. There we go. Why use end stops? Why use end stops? Why don't do sensorless homing? We can always switch to sensorless homing if we need to. So especially because this is going to be using the Do It 3, which has sensorless end stop homing capable drivers, as in the TMC 2160 and 5160. But yeah, end stops, it's good to have them, right? especially because I've never built this printer before and I don't know how well that's going to work. I also don't know if sensorless homing works for Core XY. I don't think there should be a big reason why it wouldn't work, but it's just, you know, using mechanical end stops is just the safe option, to be honest. Why are you not tightening down? It looks like this was just slightly off, because I guess this does need to sit down tight against the printed part and not against the lip. There is a little alignment lip back here, and the end stop was riding up on that, which is not what we want. Yeah, also we are following the manual. That is a good point, Chris. I will try to follow the manual for once. A bit more maybe. Don't want this to move around too much. I mean, XY homing, it's not that crucial. Like, as long as it homes, it doesn't matter if the end stop is slightly wobbly, if it moves around, and if the repeatability is off by a millimeter or 5 millimeters. It usually doesn't really matter. So, oh, there's that hex key I was looking for, but it's the wrong size anyway, so. Yeah, and I did a video a while ago on trying out how repeatable end stops are, or these micro switches are, versus something like a PL Touch, which I did use wrong in that video. The PL Touch, I guess, needs gravity, but it did still work and gave pretty good results, versus doing a capacitive, an inductive sensor, a whole bunch of those. And these micro switches were actually the best option you could have. With the lever, they are... I think with the lever they were still the best option, but if you remove the lever and home directly onto or trigger directly against that little white, you can just barely make it out, that little white actuation element, I think they were in the range of repeatability where my machine wasn't good enough anymore to measure it. So these are, you know, these are good. These are good. And if these work, like, is there a reason to use sensorless homing? It's cool, but I mean, unless you're saving cost by, you know, doing less wiring or saving the 1.2 cents that one of these micro switches costs, like, is there a reason to use it? All right, that is the micro switch installed. Both of these, both of the M2x10 self-tap, or both of the M2x10 self-tappers are installed in each end. So now we set this part aside, like we have set aside so many parts. It feels, a lot of these steps in the build feel like you're building something, and then you're just setting it aside. Like these belt tensioners, we built them 2 days ago, and we just set them aside, and we've assembled a lot of other stuff in the meantime. I guess the traditional way of building something like this would be, you have your main component, in this case the X-axis rail, and then you add parts to it. So you assemble the rail first, and then you build the bearing. Like, this doesn't even attach to that, I think. Then you attach these guys, which I think go on something like this. And you build those, and then you attach them. And then you build the next part, and you attach that. Here it's more like, okay, we're building all the components we're going to need for the next big step, and then we're going to assemble all the parts on that big step, and that's going to make a finished assembly then. So a bit of a different mindset. I mean, what you prefer is up to you, but just something I'm noticing, the way that the Voron manual is laid out versus how something like a Lego manual would be laid out. Okay, so that literally goes on the part that I just showed. So that does work like that. So we need, what do we need? We need 2 T-nuts in here, I would guess, because these aren't just going to clamp down onto the extrusion. These will actually need to go into a T-nut. Okay. And then the same on the other side. And just to get the orientation right, so this is forward, from what I'm seeing, and then I mean that's what I'm saying. Like if you just assemble the left part and then it was clear, okay, you just assembled the left part needs to go on the left. That would be cool. But like this, I have to figure out again, okay, which one was the left part now? So this goes on here, that goes on here, that is the right part. That goes on here with that rotation. There is, it's actually pretty cool. So if you didn't align the MGN12 rail correctly, there is a little slot, a little kind of garage for that rail to go into. Might be a bit dark, but right there where the rail slides in, you push that in. And boom, that is encased by the end cap now. Same on the other side. And I guess these need to go on all the way. There is something that looks like a cable routing slot back here. But I guess these need to go on all the way. So that's the way these need to go, I think. Yeah, just double checking with the two, oh god, two mismatching idlers. We have the bearing idlers on one side and we have the toothed idler on the other. Okay. That's gonna trigger some people's OCD for sure. Anyway, we need the M5x10 button head cap screw. 4 of them. Then we need T-nuts and we need M5x30s. These. Only one rail on the x-axis. Yes, only one rail on the x-axis. That was recommended to me by the Voron, by the makers of the Voron, some of the Voron designers. They're like, well, this is kind of an older recommendation to use 2 rails on the x-axis. We would recommend you to use just 1 and leave out the bottom rail, because if you use 1 rail that is low slop and this one has no discernible slop in it, M5x16 on one side. Oh, you are correct. Thank you for that. If you just use 1 rail that you know is good and has no slop, then that's going to make your life a lot easier and you're not going to get any sort of a discernible advantage by using 2. Okay, so M5x16 on the side with the cable holder, because we are screwing through the cable holder and we're bolting through. So you go like this, just trying to align this. There. And again, we can slide in the T-nuts from the end. Just trying to rough. I guess if I start out with them a bit further towards the outside, I can get the screws started. Then I can push them in, and that's not going to work. Okay, so we have to actually flip one of these, or the spacing between these 2 threads is going to be too tight. So like that, yeah. And then the same on the bottom, because there's a long screw going through this. 1 T-nut in there as well. So that's the right side. That's actually the harder side, because we also need the little wire guide and drag chain mount. All right, you catch that one. And that's caught. Perfect. So that is super hard to see. I'm sorry. That's caught, and then we have the 2. Oh, and these are almost perfectly aligned. The 2 T-nuts in there. This one goes like so towards the outside. And then basically all we need to do is catch those two T-nuts.
Thanks for bringing us along on this build. It's been great.
Well, that's a bit of a tight fit. That could have been reamed, but hey, it works. I think those are all caught. Let's try and use a Bosch again. Because actually this time we're not doing plastic to plastic, we're actually doing metal to metal with just plastic sandwiched in between. That's going pretty well. Oh yeah, and I think it does shut off. Yeah, it does shut off when the clutch triggers. I don't know how they do that because this is a mechanical clutch. I don't know how they actually turn off the motor. Is there an accelerometer in here? Might be. That feels good. And thank you for the 20, Stas, right? Saying thanks for bringing us along on this build. It's been great. Well, glad you're enjoying it. And thank you for... You will be loosening it when you tram the gantry. Anyways, thank you all for being here and helping me along with tips and, just sharing your company. That is always much appreciated. These builds, when you do them by yourself, and builds like this take a long while. It is nice to have some people that, hopefully give you helpful tips for the most part. But yeah, much appreciated, everyone who's here. So same thing again. Shorter bolts on the top now. 1 M5x30 in the top. Hex keys, by the way, super helpful to slide these nuts around. I think I might need to flip this one, yeah, because this is not. This is starting to push up against the plastic part. I actually need to get the long side away from the printer part. I could see it was just barely not lining up anymore. Just to make sure it's caught. And then these up here are almost lined up. So this one over here needs just a bit of adjustment. There we go. That maybe was too tight. That all the way on. But I guess we will need to redo these anyway when we align everything. AB motor fasteners. What do you mean? These guys? These guys? Looks pretty loose. I mean, these are both. Yeah, that is pretty. Why is that so loose? So these are. Shut up. These are sunken pretty well. And these are not. So maybe we need to give it a little more torque. These screws are too long. No, these screws are not tightened down at all.
My hypercube evolution was done in past June.
Oh, we got a bit too much torque going.
Certain this will be a great reference for later. Hoping to build one of my own to complement my Prusa.
Okay, thank you for that reminder. I never with the audio missing for the Streamlabs tips. I don't know when that voiceover is talking, but thank you for the 5, Nick. And to answer that question, whether or why this build uses all ABS printed parts versus PTG printed parts, the Voron is technically, I guess, an enclosed design. So it is a design that has panels on all sides. So the inside temperatures can get quite toasty. The inside temperatures can get quite toasty. I'm not sure how much this is actually intended to be used as like an enclosed printer. But it, like I said, it can get quite warm on the inside. Now, PTG probably going to be fine, but again, with everything on this printer being on the overkill side, it's like, well, why not go with ABS, or in my case with the parts that I printed for the Mosquito Magnum mount, why not go with polycarbonate, because you never know. So it's kind of a better be safe than sorry, and printing ABS isn't that much harder than printing PTG. So that's the entire reason there. PTG also has more flex than ABS, I think just a bit, but I wouldn't call it significant. ABS is on the softer side as well. What are we doing here? We are doing Y rails. Okay, so first we get the belt tensioners on. Okay, let me see. The front idlers are our index point for the Y rail installation. Confirm that both idlers are sitting flush with the end of the extrusion, and then install the linear rails such that they are pressed firmly against the back of the idlers. Don't forget to use your rail center guide. Okay. So these get... Okay, so the front idlers don't get tightened down yet, but they need to sit on the rail while we install everything. All right. So I hope that answers ABS versus PTG for this instance. It's not a choice that I made. It is actually recommended by Voron, by the makers of the Voron designs, to use purely ABS parts for this build. Now I just need to concentrate here a second, because these two parts are these look almost identical, but they are not. So these look like they're the same part, but they're actually mirrored versions of each other. So I think they're like that. Yeah, and one side has a little lip right there, the other does not. So, oh yeah, one side also has small hole, big hole. So just want to make sure I'm installing the rail onto the correct side, and I think that is the side with the small hole, big hole. And this one goes on small hole facing the rail. So it goes on like this. Ha! Okay. And then these also need to be aligned correctly for the rail to sit in the correct spot. But these are somewhat tensioned already, just spring-loaded, I guess. Right, and one more tip that is now 5 minutes ago from Tim Larson, 50 Danish kroners. Certain this will be a great reference for later. Hoping to build one of my own to complement my Prusa. So far, fun build. I mean, it's like just the right amount of challenge to, well, challenge as far as the manual doesn't tell you everything. You have to figure stuff out, to actually getting a functional printer. And if the hype is correct, like that is a big if the hype about the Voron is correct, and this is like the holy grail of printers, possibly very much worth it. So yeah, thanks for the 50 kronos. And greetings back to Denmark. So same thing, we use T-nuts, we use M3x8 screws, and we attach these using every second bolt hole. Now, the amount of T-nuts that are included and the amount of M3x8 screws that are included have me thinking that this kit is actually intended to be, or that this kit is spec'd out for one screw on every single one of these holes. This would be overkill, definitely, especially because these are like 5 or 6 centimeters apart. But yeah, you could probably use one screw in every hole for these rails. Tina, sorry for the enclosures. Okay, and it uses a lot of screws. Okay, so I might not be 100% correct in that. But rail goes on here. We need the rail centering device again, and these will need to go 1 over and 2 over. If you do the same thing. And then basically just fill this thing up with more of these fancy T-nuts. The anime moose. I couldn't afford a drill that isn't Ryobi. Here's the thing. I was looking like specifically for which drill driver I was gonna grab for the studio, which was a different location than what I am in now. But I wanted something 12 volt. I wanted something compact, clutch, and it shouldn't be like a $400 tool. So Milwaukee and stuff was recommended after I got the Ryobi, I think. I would have bought Makita, and all my tools are Makita typically these days. But unfortunately, Makita, I think they made a 12 volt. They definitely made a 12 volt drill at some point. I used that, wasn't happy with it. I used to have Bosch Professional, Bosch Blue tools. Used those broke 3 years in. So I was like, well, let's try something. Let's try, a $70 Ryobi kit. And so far it's been expectedly mediocre. It's all right, but it's not my favorite. So this is going to need to sit up against that edge right there. And then let's get these aligned roughly. So far that's always been working out pretty well to get these roughly aligned. I didn't need to do any readjustment afterwards. Did I accidentally get it right? No, one more missing. So one more of these missing. Oh, is that gonna work? Is that gonna work? Yeah. I think that is just the correct distance. Having one facing, because these nuts aren't symmetrical. Have one facing one way and the other one facing the other direction, and that is like almost the exact spacing for these. All right, that side goes flush. That side goes flush. And then this side goes on here. Why are you wiggling around? Going in the wrench. I mean, you could put some aluminum or something between the wrench, the vise, and your aluminum extrusion, but if you're careful, you're not gonna scrape or anything, so should be alright if you're careful. Where's my bag of screws? Here's my bag of screws. This is not gonna work. What's not gonna work? So let me just double check, because chat is getting riled up again. We have this part in the correct orientation. We have the small hole facing towards the rail, and that is pretty much what this says. Yep. So I see no reason why this wouldn't work. Rail centering guides. One here, one there. I mean, these still have just the slightest amount of slop to them, but leave out the last. Nope. I can see it. Actually, these have like a millimeter of space between them. Yeah, that does work. Is that what you were referencing to? That actually does work. That is enough space. Why is this so complicated? Can't you just build or buy a printer? You just build a printer. Well, I mean, building a printer can be, or is, a very educational and for some people actually very relaxing task to do, because you are watching your progress as you go. You're building something with your own hands, even if it's just, it's something that somebody else designed, sure, but you're making something from individual parts. You can buy everything, but some people prefer to make. And I mean, I guess the idea is also the result with building a Voron should be better than most things that you can buy, because stuff you buy is going to be optimized for... Wow. Guess I should have clamped that down a bit more. Stuff you can buy is going to be optimized for a whole bunch of different things, like cost, or designed for manufacturing, or designed for assembly. Whereas when you build something yourself, you don't care about it. You just care about getting the best possible end product. Are you still on? Yeah, you're still on low. That bit hole is gonna get annoying. And that should be all. And almost no mark. Just had the tiniest little scrape right there. That is all that we saw. Why don't you adopt kits instead of making them? Yeah, that's a good point as well. You can just adopt them. Right. So this thing basically is the same again, but mirrored. Last nut can be left out. So there, and then same thing again. So we have, where's our part? We have, just to make sure it's mirrored both ways. Correct spacing from that part that's on here, and then a double nut on the back. Okay. Just sliding it in from the side. Yeah, again, I think I've commented on that before. I believe it's easier to do it like this instead of having to tie them to the rail and then kind of trying to get them into the slot. Might be an option, but yeah, this works too. This works just fine too. Why not? What's the problem with double nutting these? You will add nuts for the ABS mounts there, and it would not ABS mount, and it would not fit anymore. Okay. So basically leave out the last nut then. But that should be easy to remove. Is there a guide in the manual about that? Because we are trying to follow the manual. Nope. I'll leave out the one that's like next up to the idler. I guess. Yeah, that's going to be tight if that's the same. That one does get an M3. So which side? Which side then? The side that has the idler on it. So skip the first hole here, or the side that doesn't have anything on here, so skip the first hole there. As if you're already giving me suggestions here. Just gonna keep popping in more nuts here. Side away from the idler. Okay. So at least on this one, if this part was already screwed down, I could just, you know, undo that last screw, and it would be good. So that last bolt hole is going to be empty then. Just use hammerheads. Oh, I could, no. I'm not going to be using hammerheads or hammer nuts. I hate those. They're the worst. But also, like, is that... I think this one on this end I should flip around. Because I don't know what's going to go into that hole on the idler. So that might have that hole. That looks like there's another M3 screw going through it and into the rail, or into the, I keep calling these rails, but into the aluminum extrusion. So I'll keep this nut on the end facing away from that, just to be safe. But then again, they're not that hard to take out at this point, because nothing's fastened in a way yet that would, you know, keep me from just undoing that last screw and taking out the T-nut. Okay, so you go on, and then the guides. See the guide? There's that guide. Now these guides are printed, so if the print is just the slightest bit off, then these rails are also not going to be centered, which I think is not that big of a deal when you're just doing one rail. But if you had like multiple rails, 1, 2, 3, something like having a, like on the Metal 90 actually, and there it has been an issue where the x-axis, you can see that behind this massive chonker of an Ego strike chain, there's a carriage down here, rail down here, and another rail up here against a flat backplate. So lining those two was a bit of a pain to do, simply because, well, any little misalignment in any direction actually would get these to bind and to run quite rough or quite hard. Tack welded into place. Yeah. I guess people are doing that with these MGN rails. Though, I mean, they're hardened, so you wouldn't really want to get them that hot. And you would want to weld them on an area where you're not going to have your block sliding over it, because this needs a hardened mate in the end. Oh well, okay, so this one's good. Now for the other one, I'm just going to need to take out no damage. No damage at all. For this one, I'm just going to need to take out that last screw and that last T-nut. So this one back here. So reverse. Now, will I be able to get that T-nut out? That is the big question. Yeah, easy. Okay, two of the, so these are the Y rails. 1, 2. We've got the MGN9 linear rails attached. Just clean this up a bit because we don't want to be spreading all these screws and stuff all over the place. More torque, more better. Nah, not on these rails. We're not loading these rails to spec. Now, if you actually look at the data sheets of what these rails can take, of course, the maximum load means it's going to have a very limited lifespan. But when you look at what sort of loads these MGN rails can take, you're going to be amazed by what sort of weight you can put onto them and what sort of dynamic forces they can absorb. I think one of these I could hang off of with like a 1/2 meter lever or something like that, and they would be fine. Though don't quote me on that. But these can take quite enormous amounts of force before you exceed their ratings. So my thinking is, if you're actually going to use that full load capacity of these bearings, then you are going to need a screw in every single hole, and you are going to need to torque them down to spec. But with this, like, if we ever get close to those maximum forces, there is something seriously wrong with the printer, and those screws are going to be the least of my concerns. So yeah. Right. So we have that. Y linear rails. Those are assembled. Left idler. Make sure you mounted your 20-tooth pulley on the A drive right side image, opposite to the way we did on the B drive. The what? Okay, so that is literally just install them on the opposite end. No, hold on. That is not just the opposite end. That is actually on the... Yeah. Okay, makes sense. Because we're going to have 2 levels of belts running around these. So one of these is going to have... this one is going to be in the lower... Come on. It's not enough to focus for you? Camera, come on.
Idlers are
but you can see what I mean.
tension
Like, one of
screws.
these has the idler in the upper level, and this one has the idler in the lower level. The idlers are tightened to the extrusion well. I guess that's what we're doing now. So with this, I guess we are installing some T-nuts. And then on the other end, we have the AB drive units. Okay, so these are going to stay where they are. These are going to stay where they are on the rails right now. Idlers are missing the tension screws. Yes, I noticed that. Thank you for the 5, Dustin. I noticed that these are missing their tension screws still. I may have missed that, so that there's supposed to be a screw that I guess the screw head is here, and then this moves this block back and forth, which in turn tensions the idler back and forth. I do wonder why that's not in there, if I just forgot or if I somehow skipped over it. But that probably should be an M3x20 or something, or 30. You just missed a step? No, I just missed a step. Okay. So that's... No, the 20s are way too short. 30s? And 3x40 in the washer. Okay. Let's see if I can find that. There's that. Okay, we got the heat sets. There it is. In the corner. M3x40 and a washer. Is that the first washer we're using in this entire build? The first washer we are officially using? Where's my 40s? Come on, there they are. They're on the table. Fantastic. That and the washer. M3 washer. They do include the oily black washers. Okay. Screw, washer, and this one just goes in here and into the threaded insert. Yeah, this does poke out and there's a little hole right there where the end of that screw can go into. Yep, and then basically the idea is you tighten that screw and you can see that that tensioner starts to move towards the screw and that tensions the belts. Okay, that, and let's do it on the other one. I think this is one of those things that you could do at any time. Even when the build is completely done, I think, you know, because this is a screw you're going to need to get to. This is a tensioning, adjusting screw. You are going to need to get to that even once the printer is completely done. So, yeah, that's going to be something that wouldn't have been too bad if I missed it right now. So those are in, just making sure that we've got everything covered. And then let's go back to flush install. These rails, M5 by 16, M5 by 16. And then we have the, so these are not going to go tight yet because we're still going to need to, I guess, install a belt at some point into those. Right, and we are going to need that belt clamp. Belt clamp. That is not the belt clamp, that is the part for the drag change, I think. Should be the belt clamps. Yeah. 1 and 2. So we have some more that have 2 unequally sized holes on them. But those we're going to need at some other time, I would think. So we need the side with the 2 holes that are the same size. And here as well. And then these go with that little notch cutout towards the empty side of the rail, so like that. And then the same on this, I would guess. So now, M5 T-nuts. I would assume the entire manual does not mention a T-nut as, well, I guess at the beginning maybe, but it does not tell you to put in a single T-nut the entire time. You're just expected to know where you're supposed to use them, which I guess is fine. I mean, in this case, it's like, okay, we're screwing through 2 parts. Now, does the screw thread into this plastic piece? Or does it actually thread into the aluminum extrusion that's underneath it? So for clarity, would be nice, but of course it's like, you know, probably 50 extra parts or 100 extra parts that you have to add to the manual, and that's just extra work. Does that work? Yes. These go in with the short side facing towards the end. Then we can line them up and get both of them in without one of them sticking out, because that's an option as well. Just have one kind of hang over the end there. Probably not as intended. So that was going towards the empty side there. And that was M5 by 16s. 2 and 2 more. I guess, again, these are not going to get tightened down fully yet, and I'm not sure if you can tighten them fully yet, because there's going to be a belt in between, which should push these two parts apart ever so slightly. Nope. Yeah, this does bottom out, so you can't fully tighten these down yet. But I'm just going to get them as tight as I can without, like, over-tightening them. What, does it bottom out? Yeah, looks like it. Just going to get them as tight as I can, just to make sure they're not kind of dangling around and sliding off. Mate OMCG is asking, hey, will you use a 0.4 nozzle or larger? Currently, that Mosquito Magnum has a 1mm nozzle on it, which is not what I asked them for, because 1mm is, I mean, kind of impractical to a point, though I guess we would be using the full melt rate that that thing is capable of. It's going to be using a 0.6, which is more reasonable, I think. 1mm, yeah, you can push out a lot of plastic, but 0.6, at least that's something that gives you a bit of detail. If I'm going to be using this printer for the printed forward program, I guess I'm going to have to use a 0.4 just so I can print these parts to spec. Should still be pretty fast. All right, AB drive units. Same thing? Same thing, yeah. Same thing with the drive units. 2 more of the belt clamps. So, with your front idlers and linear rails on your Y extrusions, now we can install the AB drive units. Press these against the linear rail and secure from the top as per the diagram. Okay, so that's the top then. This is the top then. Okay. Again, having top, bottom, or front called out in the vacuum is it's hard for me. It's like, well, I don't know which direction these parts are going to go in. I've not assembled them with a top or a bottom. Okay, but these just go on the exact opposite side over here. That's these two here. Now, which one goes on which? That is the question. I guess there's only one way. So with the rail facing towards the motor, so that's where that's gonna clamp. Yeah, that's gonna clamp with the rail facing towards the motor. No, the rail facing towards the bottom, and the motor's towards the bottom. Yeah, this is where a CAD model would come in really handy. Oh, there's a finished image we can look at. So these basically go apart. So right here, this kind of snakes out, and this kind of snakes out, which would have me think that this is going that way, then this needs to go this way as well. And then this is actually going like that. Is that the top? Guess. And this goes like that. Page 46. There goes down. Okay. Use the 3D model. Yeah, I don't have Fusion installed on this computer. I tried to do it before, but you know, you have to log in. You have to add this screen cap computer is pretty isolated here. So I don't have any logins there, so I would need to get that back and forth and type out a 32-character password. I was running out of time. So cool. that there. So same thing on this side with the belt clamp. Thought I had already grabbed those. Nope. I already see one more. We have more of these. I think, yeah. There's two more. So yeah, we were just looking at 55 just to get a reference for where everything's going to go. But these first. Press these against the linear rail. Okay, so these actually go all the way up against that linear rail, and then we have the same thing here, but we're not screwing into that side yet. We're just screwing into the bottom side with the two M5 by 16 screws. All right, and I guess the other side we're going to do once we do adjustment and stuff. So this side, same as before. In and in with an M5. What are you? What are you doing there, little ball? And that's okay, but that's not that shouldn't be a bearing ball, because the bearing balls in the MGN9 are a lot smaller than that. I'm thinking it's one of these. Let me see if I can find the one, because that would be odd that I had lost a ball there. Well, these all seem to have their balls still intact, but maybe we've already used the one that had lost its ball, because that is exactly this ball size of the T-nuts. that was scaring me there for a second, but I think it's just one of these. And these still work without the ball. The ball is just to keep it in place during assembly. But then there must have been a spring somewhere. And it's definitely not in the bag. Okay. A bit of a shocker. I mean, if just in case, if we had ruined one of these rails, we do have a spare. We do have one more rail that, you know, I decided was the worst one, and, you know, would be the one that I'd avoid, but of course that means having to pull off one of these rails and replacing it. Stressful, I'm telling you. No spares. The thing is also, I do have more of these rails. I'm not sure if they're the correct length, but I do have an angle grinder. I could cut one down to size. So, just in case, I mean, we wouldn't be screwed here, but yeah. We've come back from worse. We need the plate. Random extra that wound up in the bag. Well, you wouldn't ever need that as an extra. You wouldn't ever need one of those balls as an extra, because they're only useful if it's actually inside your T-nut. If it's in here, if it's just outside, there's no point in having that. So does that actually? Yeah, that does clamp down. I need a quick sip of water here. Only using one on the X because it's been determined by... okay, that's about the rails, yeah. So yeah, why am I only using one rail on the x-axis, well, because it's been recommended like that to me by the Voron team. Makes it easier to assemble, makes it easier to assemble it without having these rails constrain each other and kind of tension each other and cause issues like that. And one linear rail is still strong enough to accurately support the toolhead. So that's in there. Next, XY? No, this is the Y rails. Same procedure as last year. The ball is only useful inside the nut. Yeah, I mean, that's what it is. So you go on here and you get pushed down onto the linear rail on the other side here. Nope. What I'm just realizing is with other printers like I guess the Prusa series and stuff, that's the one that is historically the most diverse in that regard, where with other printers you could build the printer in hundreds if not thousands of different ways, especially when you build different combinations of designs. You can add T-nuts on the bottom of the y-axis extrusion at this point. What? No, those. I don't know which ones, but well, in a second. With those, you can like pick and choose parts, and you like there's community upgrade parts where it's like, oh yeah, this part that didn't work for me. I built it in an entirely different way. With Voron, because it's a relatively fresh project, at least from my perspective. It's a relatively fresh project that is done by a team that actually runs the design process more like an engineering team. You don't have that as much. You have one design, and that is what's the word for that? That is the one definitive design of the Voron 2.4. Of course, there are revisions. There's the Voron 2.0, 0.1, 0.2, etc. But there's not like, oh, this is the John's Voron improved V5. There are lots of mods, yes, but as far as like building the printer goes up front, it feels like this is just a very unified, streamlined kind of design. Just random notes I'm making here. So we've got those. So those are clamped down with the belt clamps only so far. Right, and I'm just trying to see where that part is where we actually assemble, where we tighten down the bottom, the rail sides, because so far we've only done the top with belt. I guess these are belt clamps. These look like belt clamps. But then down here, there's two more. There's what looks like an M3 and an M5. Also belt clamp. Huh. Interesting. I'm kind of missing the point where this would be tightened down to the aluminum extrusion by itself, because this is still transferring the clamping force through the belt always. So when you undo the belt, you're also loosening these ends here. Though they are going to be, even when there's a belt pulling on them, they are resting against the rail. So the rail transfers that clamping force that the belt exerts and kind of keeps these from sliding around. So, okay, so that's going to be done later on the bottom. Okay. Let's just continue with the build. Thank you, Dirty Harry, for the for calling out the need to give them some thumbs up on these streams. always appreciate a thumbs up. But I also appreciate everyone who's just here watching and tagging along, like I've already mentioned. Just some company to have during these builds. Rear brace extrusion. When you install your M5x10 fasteners, leave the back brace slightly loose. You want this to be able to move in the later steps, but don't leave it such that it will pull apart as we're working on it. Okay, so basically just lightly tighten it down. Lightly. Gently. That. Nope, that's the wrong lyrics. That's not the lyrics I want in my head right now. Nope, not on the live stream. Okay, we're gonna tuck these in gently. So M5x10 all around. M5x10, 2 up top, 2 in the bottom. Yep. There's that ball again. Goodbye, ball. Okay. Can I get you in like that so that they're facing away from each other? I think I can. That's going to be interesting to align. Like so. Oh, that's a tight one. But I think that is going to be... That actually aligns perfectly. So with that hole... So that one still has it covered, but this one all the way down here, I've got the T-nut just flush with the end on the long side. And this slides in. And the hole, this one, aligns perfectly. Okay. So that makes it easier to align that one. Now, can we actually align the other one if we just flip this one around? The build goes on and on and on. Yeah, like I said, I mean, if I'm liking this build, if you guys like this build, maybe we can think about doing a V something next. I don't know, maybe do a... So the thought is maybe just do a live stream build series like this every 2 months or so. And just pick a different printer, because I've already seen so many good community designs suggested that we could build live on stream and ruin the supply chain for one of these printers in the process every 2 months. One of the guys making Voron parts has already written me an email, was like, hey, thanks, but like, you know, we're not going to have any parts in stock for the next couple of months. Oh well. That's what it is. So these just go in. Yeah, there's no top and bottom at this point. And these are supposed to stay slightly loose. How about a V0 in the future? I mean, Stefan has already built a V0. From what I hear, he's happy with it and now wants to build a 2.4. But yeah, V0 sounds nice. Just build a really small one. V1. I mean, they're all exercises in building a printer in a different style, right? The basic kind of engineering style is the same, but the kinematics are different between the 0, the 1, and the 2.4. So, yeah, what's the... I mean, like the thing with the names too, like, you would think a printer that's called 2.4 would be a superior design to a printer that's called 1.8. I mean, it sounds like it's just a straight upgrade, but it's not. It's literally a different design family or a different design history. And then the switchwire and legacy. Now, can somebody explain how those relate to each other, and if they have some sort of an intended use? Because for me, it's just like, well, it's another design, and I don't know, was there even a reason why I chose the 2.4? Was the highest number. No, the reason why I chose the 2.4 is because it has a static bed. It has a non-moving bed, which I need for what I've got planned for this printer. Is that screw the problem, or is it the T-nut? It's the screw! Switchwire is a Core XY bed flinger? Oh, so it actually, okay, so it has the bed on the Core XY. Ooh. Legacy is a throwback to the older design. So Legacy, is that actually a printer that's called Legacy? Like, doesn't sound like you'd want to build it. It's like, you know, Salesmendel is a legacy design that we're just keeping around for, like, what's it called? For sentimental reasons or whatever. We're keeping that design alive. So Resto mod, okay, that makes sense. So it's not a design that would be designed today, but it's like an older design that's brought up to current standards, I'd say. Switchwire is Core XZ. Okay, that makes sense. And then V0 is just standard Core XY with a Z-axis bed. Why isn't it Core XYZ? That would be quite the chaotic belt setup. Core XZ turned out oddly nice, huh? I mean, there is some. I keep talking about the idea of having what's it called? Not aliasing, anti-aliasing, or dithering in those. Well, the thing is, if you have Core XZ, you are running the Z-axis with a stepper driver with no gearing, typically. So on this one, on the Voron 2.4, you have a geared down Z-axis that's like 1, 2, 4? If it's a 20-tooth pulley. So one rotation on your stepper actually means 1/8 of rotation on the, or 1/4 of rotation on that pulley. It actually drives the Z-axis. That's Y-axis, but that drives the Z-axis belt. So you have that Z-axis resolution. But if you have a Core XZ, as you're moving the X-axis, your Z-axis, well, what would typically be your Z-axis motors also rotate, because their movement, or the movement of that one motor, is also compensated 100% by the X-axis motion. So basically, you get a bit of a wobble on the Z-axis position as the X-axis moves. So that could actually that basically takes out any need for having a high resolution Z-axis drive or an X-axis drive, because X-axis not that much. Yeah, X-axis too, right? Because as your X-axis is moving, the Z-axis is also moving, so you're also getting a bit of dithering, I guess, on that X-axis. So something like a Core XZ, as long as your X-axis is moving, doesn't have a theoretical resolution limit on the Z-axis, right? There's a lot of cool and crazy kinematics going on with the entire Core XY or Core XZ platform. With a Core XY like this, all you're doing is basically one motor moves the toolhead diagonally this way, the other motor moves the toolhead diagonally that way, and if you want to move just in X, you turn both against each other, and if you just want to do Y, then you turn them the opposite direction, then that compensates each other out. So here you still get kind of the resolution limit if you. It's basically like your printer is rotated. Your printer is rotated by 45 degrees. If you want to print a model that has like, you're still going to get you're still going to get tree ringing on a Core XY platform, whereas on a Core XZ, at least the. And anyways, getting too complicated here. I want to build a printer. But that's the sort of thoughts that go through my head when I see all those different designs of it's a Core XC, a Core XY, a Core YA, whatever. But yeah, there's a lot to it. Rear brace extrusion, we've done that. I've rotated my Core XZ 90 degrees, and now I have a Core YZ. True. Basically, I mean, what's X and Y is just depends on what your definition of this side is forward is. Right. That's the X-axis brace. Don't we have? Doesn't this have? Hold on. Does this not have a? There's nothing going between these, right? Aha! Hope you didn't hear that, but that was my knees. Yeah, the only thing going between this is the actual X-axis. So I guess that's what's next, right? Got that. We've got that. We've got that. So next it's just our X rail, and there is a. We're going to need the overview drawing just to determine which direction this goes. So, there. I'm realizing I have this thing upside down, which I need to have because I need to screw into these. So now we have our little red drag chain snout going towards my left. That faces down. So theoretically, that should be the correct orientation here. Ah! Okay. I need to put something underneath these because that's gonna correct. That's already made some unpleasant noises that I don't want to hear again. What can we use here? Oh. Always when you need them. Actually, 2 should be enough. There we go. Got a bit of a spacing going on. So keep in mind, this is upside down. So the motors are pointing up. This is exactly the other way. So the orange snout side should point towards my left. So my left here, your right. So like that. That's, I think, the same way I had it before. I mean, it's gonna move fine both ways, but that looks correct to me. That looks very correct to me. As long as the X rail is facing towards you, it's fine. Okay, that's easy. It is. Okay, so now I just need to find the point where we were with the assembly. No, that's too far. Just 2 on one side? Now, which side is that? That would be my left, I guess. So 4 on... Well, it doesn't actually matter which side I put 4 into and which side I put just 2 into, but is that correct? 16s. There. Prusa Mint boxes are spacers. Yeah, they're good spacers. They're the quickest thing I had within reach that was thick enough. And yeah, at some point, Prusa decided to just send me their entire assortment of filaments. So I have a few of these boxes. So my... Oh, screw it. This set's getting 4. The XY joints are slightly different. Well, yeah, so I guess you could make out that this side has the spacer closer down or further down, and this one has kind of like that extra layer for the other layer of belts, but too much brain. And it's just one side, and it doesn't really matter which side. Prusa XL when? I've no idea. Ask Prusa. I mean, I guess we all know we should be expecting something like that at some point, but when exactly? No idea. This is under slight tension actually, but I'm just gonna butt these up against these stops that are still in here. And that should give me a base alignment actually. Is there something saying how to tighten these down? Nope. So basically, as long as these in the back are roughly square, this is going to end up roughly square as well. And it will want to spring back. But possibly we're going to have to, loosen these again at some point and align them. Remove ones you need to when you need to. Okay. Guess we could put 2 more in here, but whatever. Micro switch pod. That's one more thing I'm not gonna do yet, because for me to install the micro switch pod, I would need to have the micro switches wired up, which I do not. That would go. Oh, hold on. There is a reason why there's only 2 screws. Ha! It's because that's where that micro switch pod goes. Okay, makes sense. So we're actually screwing that. So I will be installing that just to get the just to get all 4 screws into this one. And I guess when it comes to wiring up, I'm going to take this off again and just wire up these switches. Okay, so it's nice to feel that this is smooth, but then again, when there's no kind of cross beam element here, it would be weird if it wasn't smooth. So if you actually go over here, yeah, it is definitely getting tighter over here. So we're gonna have to undo these at some point again, and just adjust them and make sure that this is all good. Because right now what's happening is either these side rails are going like this or like that. So the distance that this X crossbar mandates is not the same as this rear bar is giving us at this point. So this rear bar is either too short or too long. I'm hoping it's too short, because that would allow us to adjust it. If it's too long, wouldn't be that back. I mean, there's no way we could adjust those. So yes, I can take out the stoppers at this point on the x-axis as well, because it can't really, like, none of these carriages can fall off at this point. Okay, so let me check the manual first before I take this off and get into a not so safe state. No. I was going to do SC, not SS for starting soon. Next, the toolhead. Oh, look at that. 2 blocks in there. I'm only going to use 1. And this is actually where we're going to use, those parts that I printed with some heat set inserts. Whew. Ow. Okay, you are already a lot more rigid. And so that's what I mean. Like, we're taking another part and we're setting it aside. I guess we're gonna install the x-axis in a minute, or the x-axis, the tool head in a minute. But we gotta assemble the tool heads first. Hands off the buttons. What? You have to loosen those again. Okay. Whip out that soldering iron and attach them. I would rather, so with wiring and with soldering, I will whip out the soldering iron, sure, but not for soldering those up. For doing wiring and crimping and soldering, I would much rather do that in peace without the live stream watching. Like, sorry, but there's, first of all, I would be forced to make wiring entertaining somehow. Second of all, I know you're all staring down my neck and you're just waiting for me to mess up. So I want to take my time. I want to do that properly. And wiring, well, we'll see about wiring exactly, but at least the stuff that's crimping and soldering and all that, I will do off camera. I'll make sure it's done, and then we can do stuff like the first print or firmware config. We can do that together again. Crimping stream, Nero's always saying done 4 wiring streams, and it does get old quick, because it's just wiring. The thing with wiring is it's just you're doing the same thing 50 times. And it's like I don't know how watchable that is. But I do know that my fingers are covered in grease or oil from those bolts. We need an open source wiring processing machine, sure. Or at least, actually, if you know a service like that, that allows you to order custom wiring harnesses. I know Egus does that. But of course, with anything Egus and with stuff that's made in Germany, it's heckin' expensive. It is a service that's like useful if you do industrial stuff and if you need like super high quality control and reliability. But if you know something like JLC PCB for wiring, that would be super useful, because doing wiring looms is something that I don't think anyone really enjoys. And China might have the machines to do it in bulk and to do it efficiently. But yeah, if you know something like that, let me know. And yeah, if you do like wiring looms like these. Also, so just for context, these wiring looms, this is the one from Lineo, link in the description as well, and the one from Fermi Labs. These are about $120. So $120 for 2 dozen connectors basically, and some wiring. So that kind of gives you an idea how much effort goes into making these. So you can do that yourself if you want to, but that's going to be disproportionately more effort than just ordering them and having someone do it that has the setup for it and can do it efficiently. But yeah, if there's something some service that does it for cheap. Even if it's just like 5 different connector types, that would already be enough. If you know something like that, let me know. So next up, we're going to do the carriage, as it is commonly called. So that's hopefully what we're going to end up with, maybe with some parts with slightly different proportions. The carriage, heat sets. So heat sets go in there. So this is, like I said, this is polycarbonate. Gonna be interesting how well these heat sets go in here. Theoretically, this should be the one. I have reamed all the M3 holes on these. I've used the, what's it called? The countersink. Wow, that's not doing anything. That's set to 230 and it's like, that's barely moving. Okay. I've done the countersinking on all the M3 holes, like in here, just so that they would, line up nicely. And just so we wouldn't have any issues actually getting M3 screws through them. Say that 5 times quickly. So 280. Let's see if that's better. Kinda? Yeah, the magic of polycarbonate. Guess we need a little more on that. So, hi there, soldering station. So these parts are parts that I printed actually yesterday on a Mark III with, again, Prussiament PC blend. So they don't look quite as nice as the printed forward parts that were done on an actual Voron. The wiring looms, there are not, well, PTFE, PI, P something high temperature and super flexible. That should be good. So that took 290 degrees Celsius to go in about as quickly as 220 or 230 into ABS. So definitely better heat resistance on the polycarbonate parts. Have I had my hands on the Prussiament PCCF yet? Nope. This is just regular Prussiament polycarbonate blend, PC blend. M3 by 30 and some hex nuts. My buddy's sending me photos of how they're grilling out right now. And I'm here in my studio, in my basement, no sight of daylight, assembling a 3D printer so you guys have something to watch. What a life. M3 by 30. So we have 2 nuts on the side and 2 screws from the left. M5, M3. Warranty sign saying, hey, the PTFE wires are life, the jacket is thin, and they are wear resistant. Yeah, that's one part, but also the makeup of how the actual wires on the inside are made up. If they're very coarse, like the stuff that comes stock on the Mosquito Magnum Plus, even though the length would be good, but this stuff is like so rigid you can see the inside here. Maybe you can see the inside of these wires. These are like so stiff and rigid. Like if you bend those a couple times, they're gonna break. That's also something you need out of a cable you're gonna put, especially into a drag chain. Still looking for my nuts. There's my nuts. Ah, spilled them. So that goes in this side. Oh, that's going to be a tight fit. Okay. One here, one there. There's nothing actually going into these parts yet. So the fact that this is a two-part assembly is, from what I can tell, purely to make it more printable. This could have been one part if you were to use supports, but to make it more printable, I guess it was split up into two. So now we get to put them together again. Does have some torque. Come on, grab. Okay, that doesn't work. Nope, now that nut is in there. At an angle. Don't want that. Why is this one so hard to grab onto? Try that by hand, maybe? Okay, that's grabbing. Yeah, that press to operate, press to start kind of thing is slightly annoying at times. Because you don't have that much control over what's actually happening. Is this the comedy bit? Somebody just asked, hey, what type of screw is more common? Stainless steel 304, 316. First of all, we don't call them 316 or 304. That is American denomination for, you know, what is typically called A2 and A4 here. So A2, the lesser grade of stainless steel, I think that's 304, is relatively common, and especially on small sizes like M3, is actually becoming more common than getting galvanized screws. But the 304s are all made in China, 100%. Like they're all imports, and you can get them in bulk, and they're cheap that way. But for larger parts, I mean, A4, the more rust-resistant stuff is always more expensive. But for larger stuff, there is a real price difference between getting stainless and getting galvanized, and galvanized usually is a factor of 2 to 3 cheaper. So yeah, I'm still a fan of doing galvanized wherever I can. All right, so we've got that. Just making sure we've got everything covered. Heat set into a, what is that part? That's just a clampy part. What's the order of these? Okay, so we're heat setting these into that part, and then we are grabbing the sensor, and then we're attaching the sensor and screwing it into the heat set. So that's kind of a an adjustment slidey bit. Question is just, is that an accent part? Or is it this one? Because oh no, that's the one with the 2 nuts in it. Okay. So that, I think, would be the one. Titanium hardware. Yeah, if you're rich. Is that really? That feels like it's very loose for a heat set. That feels extremely loose for a heatset. Like, hole size is different too. Is there a different part? I know we have the accent colored ones with you. Oh, that one's squished. We have the accent colored parts for, I think it was the drag chain at some point. But that should be the one. Just double checking against the sensor just to make sure we have the correct hole spacing at least. What sort of sensor is it? This is a Zhongde. This one. That is the type of sensor that is included, and I think that is functionally the one that is required. PL05N2 NPN normally closed. 6 to 36 volts. Five millimeter sense distance inductive probe. Okay, makes sense. So with the powder coated spring steel bed that we're going to be using, that should be a good match. That should give very reliable readings. And hole spacing here is, yeah, seems to be correct. So I think we do have the correct part. Oh yeah, and it does have that little bit of a round over that is visible in the manual. Like you can see the side facing away from the heatset inserts is kind of rounded over, and that's this side. So we're actually going to install these the absolutely correct orientation too. Just might be poking through with the. Oh yeah, I'm poking through with my soldering iron. Guess we're doing this floating. Yeah, just trying to make sure these are flush on both sides. So this part is exactly the same height as the as those inserts. LSC wrote, "Hey, guten Abend aus dem sonnigen Florida. Greetings back and good morning or good noon back to Florida." All right, that's in there. What drove you to the decision to use an inductive probe instead of a BL Touch? That's not a question for me. I guess that's a question for the Voron team, because that I didn't make that choice. I didn't choose this probe. This is the probe that was included with the Formbot kit, but it is the type of probe that is required by the 2.4 design. So basically, M3x20s. Okay, that was what I was looking for. M3x20s. Those give off a very high-pitched sound. I'm not sure if you were able to hear that, but that is very shrill in my ears. So we do have what looks like a wiring guide in this part, so that's the orientation that's going to go. Probe goes in here. Wow, probe really goes in here. But yeah, I guess you can still move it around, and then up here, wire can go out like that. That is built-in wire management, but when you adjust it, it's like, well, so it kind of goes all over the place. At some point, I'm going to need to have a connector on this wire because I believe this is still going to feed. Well, this is still going to feed into the wiring loom. So I'm going to need to connect this to the wiring loom. I'm not going to have this cable in the drag chain itself. But screws go through the probe. Like that, and then into, oh, that's a tight fit. Into, well, I guess I'm going to screw them into the side that is the back side of where we inserted our threaded inserts. So we're not pulling those out the same direction that we pushed them in, or the opposite direction that we pushed them in. So we, as this gets tightened down, this would push the inserts in further. That's kind of my thinking here. If I can actually get this guy in here. Okay, so those parts printed on the Prusa were a bit tight. Like the specs that these parts need to be printed to are pretty tight from the start. So the printed forward parts are all done on Vorons. And as if I remember correctly, you have to qualify for being able to provide for the printed forward program, which, again, this is a part I printed myself, and there's a reason why they have that qualification process. If the tolerances are off, you're going to have not that great of a time assembling it. So, okay, that's going to be a bit of a tricky one to adjust, but we'll cross that bridge when we come to it. I'm just going to tighten this down for now in the lowest, most extended portion so that when we do a homing run sometime in the future and I forget to adjust it, at least we don't crash the hull. And though that shouldn't be, according to Slice, that shouldn't be a problem. There is that. So, next, X belt retention. 2 more heat sets. Cool. Good thing the iron is still on. And those are accent parts from what I've seen. So this one and this one. Prusa not up to the tolerance. Yeah, the thing is also polycarbonate parts printed in the basement is slightly warped. Ever so slightly. Like there's a minuscule amount of warp to this and to this part as well. So the fan shroud here. On this one I don't think it matters all that much, but of course here you get that that clamperoni effect. These are not printed forward parts. This is not printed forward parts either. These are parts I printed myself. Just want to point that out again. Right. Inserts into these two. I'm gonna poke my table again. 230. Oh, that's actually perfect. Iron bottoms out at the exact point when this thing is fully inserted. There is the hot. There's those two. And those go in with an M3x12. M3x12. That might be the first M3x12 we use. From the side. From the side in here. Okay. And there is, yeah, so at some point, there's going to be a belt in here. There is that belting texture in that surface that we're going to tension or clamp these against. So these are going to hold a belt at some point in the future. I gotta say, I am liking the use of all these threaded inserts. Because they're a lot nicer to work with than having to juggle around square nuts or hex nuts and kind of having to keep them into place, or having to keep them in place. And the thing is that they're quick to install. They are set in there permanently. They don't wiggle around. They give you a slop-free assembly. They can't fall out. I do like these, and they're pretty cheap. Like, they're more expensive than nuts, but in the end, like, it's maybe €1 more for the entire build if you use inserts instead of all nuts. So yeah. Button head option. If you have M3x8 button heads, you can use those here, but I don't think we have any, and I certainly don't have any in my assortment. All right, so at this point, so we are actually going to attach this to the rail now. This is getting serious. You're empty. I don't know what was in you, but so we're done with heat set inserts for now. We're done with that. We're done with that. That's going to stand up, okay. So, this way's up. The motors are down, which means the probe needs to go down. That would be my best guess of how this is supposed to go together. So the button heads are going to stick up, or the socket cap heads are going to stick up a bit. And button heads, yeah, I can see that. You can't see that because that is tough to show, but basically in here where those red accent parts have their cutouts, we have 4 screws that tighten it down onto the carriage. And the... God, if I can get you back out. The socket head screws, they're going to stick out a bit further, and they may interfere with... Come on! They may interfere with getting the belt fed through the exact correct way. How am I liking the Bosch driver so far? It's all right. It's okay. I mean, I guess if you use it in a situation like this, it's good. You just don't want to use it for doing like super low torque stuff, like threading into plastic, or I don't know, having a nut that pulls through a plastic piece somehow. For this, it's all right. The activation with I've so far I've only used the push to activate. I've not used the button. But that push to activate feature can be a bit annoying at times, because it can activate accidentally, but the torque limiter seems to be doing a fine job, so it's okay. It's okay. It's all right. I'm not like super stoked about it, but it's okay. It's usable. Motion of the x-axis looks really smooth. Oh, we're hitting an end stop. It is fairly smooth. Can a push to activate be turned off? No. No, the push to activate is always on, unfortunately. So you would need to take out whatever sensor is in here that that senses that. You would need to like physically open that up. So unfortunately not. That's the bottom rail that we're not using. Oh, so it's on a swivel. Okay, that's interesting. So the bottom rail attachment point would be on a swivel mechanism as well, just to take out some of that over constraint. But since we don't have that bottom rail installed, we're not using that. We're not going to have to do that. Whew. Cutting belts, securing belts. All right, you know what? That sounds like it's a high concentration job that requires me to not mess up. So from what I've read, the belt cutting thing, bit tricky. Belt routing also pretty complex, and I'm feeling my concentration to fade. So I'm gonna call it quits for today. We do have a functional XY core XY gantry with a long stick out probe that is binding on this side, unfortunately. So next time, toolhead finished, belts, this thing's gonna go in the printer. But today, that's gonna be all. Let me just scroll through here real quick. I think next time we should have a, extruder as well. We should have a mechanically complete printer next time. Next time it should look like that pretty much. So thank you all for sticking around. Thank you all for watching. Thank you all for subscribing. How many new subscribers do we have? We have probably 12 new subscribers. Thank you for that. Welcome. And yeah, do that thing. Do the like, do the subscribe, leave a comment below. And have a great Saturday and Sunday. Thank you for the 2-call. Thank you for everyone who tipped during the stream. And just everyone who was giving useful or not so useful tips during this live stream. Have a great day. I will see you all on Monday for the next stream. Bye.